We've spent a long time talking about congruent triangles. Now we're going to talk about a different concept called similar triangles. Similar triangles and similar figures in general have the same angles, congruent angles, but their sides are proportional, which means that their ratios are equal. And just like we had different theorems for congruence, we also have them for similarity. But we only need 3 for covering similar triangles. There's AA for angle, angle, side, angle, side, we still say sassy, and side, side, side. So when we're looking at AA, if you remember when we were talking about congruence, we called it AAA, and that was not necessarily meaning that our figures were congruent, but it is enough to say that they are similar. So if 2 angles of a triangle are congruent to 2 angles of another triangle, then we say the triangles are similar. And the symbol for similar is a little tilde. Then we have side, angle, side. But unlike with congruent triangles, when I'm talking about these sides, it means something a little different. If in 2 triangles, a pair of corresponding angles is congruent, so we still need congruent angles, and the sides, including the angle, are proportional, then the triangles are similar. So we're not saying that these 2 blue sides are equal. We're saying that they are proportional, that they end up with the same ratio as these red ones. And last, side, side, side is like what you think. If all 3 pairs of corresponding sides of 2 triangles are proportional, then the 2 triangles are similar. So now we're going to look at a few problems. Are the 2 triangles similar in example 1? That's really the question we're going to ask in everything. So when we look at a problem like this, what we want to do is imagine 2 triangles. So you have this little guy, and then you have the bigger one around it. And what I notice when I look at this is that they both have the same vertex angle, and then they both have an angle that is congruent. So we would say, yes, these 2 triangles are similar. Similar by angle, angle. Looking at the next one, I have vertical angles, so I know those 2 angles are going to be congruent to each other. And then remember, those arrows mean that we have alternate interior angles. So if I make my Z, the inner corners of my Z are congruent. And you could have gone the other way with your Z and get that 3rd angle, but this is enough to say that these 2 triangles are similar. And we should be doing our congruent state or our similar statement. So going back to the first one, so triangle XWV is similar to triangle XZY. And then in the other one, we have triangle HJK is similar to triangle HFG. All right, looking at the next one, I see I have my included angle. So now I'm going to check and see if the sides are proportional. And I'm going to do it with reducing fractions, but you could also type these fractions into a calculator and see if you get the same decimal. So what I suggest doing is seeing if your short side over your short side equals long side over long side. So my shortest side in the first triangle is 4, and I'm going to see if I can put it over the shortest side in the other triangle. And we're going to see, is that equal to, I'm just putting a little question mark, the long side of 6, long side of 9. And so I'm just going to reduce those 2 fractions. So I can reduce the left one by 2, which gives me 2/3, and the right one will also reduce to 2/3. So we would say triangle M and L is similar to triangle PRQ, and that is by side, angle, side. But once again, sides here aren't meaning congruent, they're meaning proportional. The next picture is another one where we have the kind of, I call them overlapping triangles. We have our little triangle here on the inside, and then we have our bigger triangle on the outside. So I'm going to go ahead and find the links for the bigger triangle. That is 9 by doing 6 plus 3, and then 15. So my short side of my little triangle is 6. Short side of my big triangle is 9 equals 10 over 15. And we're going to see, is that in fact true? So we'll reduce. I can divide those by 3 and get 2/3. Divide those by 5 and I get 2/3. But that so far is just talking about two sides. Where does my angle come in? Once again, it's an overlapping triangle, so angle L is in common with both. So we would say that triangle LKM is similar to triangle LEJ by side, angle, side. The last ones are side, side, side. How do I know that I'm given all three sides? But when we do this, I say it's like when you're driving through and you have small, medium, and large drinks. So I'm going to put the small side over the smallest side. So 7 over 21. And we're going to see, is that equal to medium? I should write my little small, medium, large. Okay. Medium, 12 over 30. And large, 15 over 45. And then I'm going to reduce those fractions. So 1/3. And then what's the biggest thing that goes into that would be 6, which reduces to 2/5. And then we get 1/3 again. So are those all equal? No, those are not all equal. So these are not similar. Okie dokie, last one. We once again have a little overlapping triangle. This time they're trying to be sneaky and they did not give me my red sides, my little tiny triangle sides. So I'm going to do 88 minus 56, which is 32. And then 143 minus 91, which would be 52. And once again, we're going to do small, medium, large. So small for my red triangle is 32. Small for my big triangle is 88. And we're going to try that with the medium, which is my base, 44 over 121. And then large, 52 over 143. Okay, so we have some larger fractions in this one. So this would be something you could definitely type in the calculator is fine. The first one, my biggest factor that goes into both is 8. So 32 divided by 8 is 4. 88 divided by 8 is 11. And then I start kind of using that. Let's see, 44 is divisible by 11. 121 is divisible by 11. So that reduces to 4 over 11. Let's see, wouldn't it be really nice if I could reduce 52? So we're just going to kind of see if this works out. So let's see if 143, and y'all have calculators, so you can do that. Yes, okay, so that is also going to reduce to 4 over 11. Yay. All of them are equal. You have to try all of them. You can't just stop after the first two, which is what a lot of people like to do. And now we can say our similarity statement that triangle LKM is similar to triangle LDE by side, side, side.